Okay, 2.3, polynomial and synthetic division notes. So long division always works. Synthetic division is only works on special cases. So when we divide, we're talking about f of x is the dividend, d of x is called the divisor, q of x is called the quotient, and r of x is called the remainder. Okay, how we look at this is we have f of x over what we're dividing by, our divisor, d of x. That equals our quotient, which is q of x, plus, since we're dividing this whole thing by d of x, then it's your remainder, r of x, over your divisor. So back when you learned to divide and then write things as like mixed numbers, you would write it over the remainder, way back when, before the decimals. This is like our notes that we're doing it in. So if I was dividing by the d of x, you'd have to remember to put it over the remainder. Okay. On a division part, we have d of x is the divisor on the outside. Okay. Dividend, what we're dividing into. So in our case, it's going to be our f of x. And then after we get done dividing, we would have our remainder. Okay. And then this is on top is called our quotient. So if we had 60 divided by 13, we'd put 13 outside and 60 inside. We're not doing decimals, so we're not putting a decimal point or anything like that. I'd figure out how many times you need to multiply 13 by to get to close to 60. And so I have 4. And then I would take 4 and I'd multiply it by 3 and I'd get 12. I'd carry the 1, and then I do 4 times 1 is 4, and I would add the 1 and I'd get 52. Then I would remember to subtract. We started to get lazy and not write our subtraction sign, but we would subtract and we'd get 8. So what we would have is 4 and 8/13. Okay, so we learned to do our mixed numbers, and that's how we would end up writing that, 4 and 8/13. So this is very similar, that 4 and 8/13 is the same thing as 4 plus 8/13, because if I add them together, I get 4 and 8/13. So we're going to take p of x, and we're going to divide it by d of x. So p of x is what's going to go in our box. You always want to make sure what you're dividing into. So our dividend, what we're going into, has descending order and a spot for everything. So this one goes 3, 2, 1, and then our constant. So we're good. That one's in this proper order. So I'm doing 2x to the third minus 9x squared plus 7x plus 8. My divisor is what I'm dividing by, and that's 2x plus 1. How we do this, we're going to have a little side chart over here on the side. This is like my work area. This will help some people. Okay. So what we do is we do our first term with our first term, our leading one, and with our leading one. We're taking 2x cubed, and we're dividing by the 2x. We'll worry about the plus 1 in a minute. That gives me x squared. How I like to look at it is, what do you need to multiply 2x by to get to 2x cubed? Well, you have to multiply it by x squared. If you multiply 2x by x squared, that will give you the 2x cubed. It has to be the same. Okay. Now, when you did dividing long division with digits, okay, when you did long division with digits, you would then look and be like, this is 2 digits, so you would go over the second digit and you'd have to put it up there. Okay. This is 2 terms. So it's gonna go over the second term if you want. However, if you just get them up there, we'll talk about how you know where it goes in just a second. So it's going to be x squared. Then remember, we took this 4 over here and we multiplied it by the 3 and the 1. So I'm taking my x squared and I'm multiplying it by my divisor, which is 2x plus 1. That means I need to distribute that. That gives me 2x cubed plus x squared. So I put those under their perspective spots. So 2x cubed, these should match, plus x squared. What do you need to remember to do? You draw a line and you subtract. That means change your signs. This one's a minus, this one becomes a minus. When I do that, this cancels out. Woohoo! This -9 minus 1 is -10 x squared. I'm just drawing my line. I like to bring them all down so I don't lose anyone in my process. So I bring down the 7x plus the 8. Okay, now I look again. What do I need to multiply my first term to my first term? So what do I need to multiply 2x by to get to -10x squared? If I don't know, I come over here and I'm dividing. -10x squared divided by 2x. That gives me -5x. So I'm taking my -5x. Okay, I'm going to put -5x up here. I then have to take that and multiply that here. Okay, so if you need to see that step, I'm multiplying it by the 2x plus 1. That gives me -10x squared minus 5x. Put those under their spots. -10x squared minus 5x. Draw my line. What do you need to remember to do? Subtract. That means change your signs of your second one so they become pluses. This cancels out. Woohoo! 7 plus 5. X is 12x. Bring down the 8. Now I look again. What do you need to multiply 2x by to get to 12x? Some of you see it right away. Some of us don't. So I take my 12x, divide it by 2x, and I get 6. So I'm going to put plus 6. What am I doing with that 6? I'm taking that 6 and multiplying it here and here. So I'm doing 6, and I'm times it by 2x plus 1. That gives me 12x plus 6. 12x plus 6. What do I need to remember to do? Subtract. Make that a minus. Make that one a minus. This cancels. 8 minus 6 is 2. This is now a smaller degree. This is a degree of 0, where this is a degree of 1. This is now smaller. It doesn't have an x than that, so that's your remainder. How do we write a remainder? We write it over the divisor. So our answer, our quotient, is x squared minus 5x plus 6 plus my remainder 2 over my divisor, 2x plus 1. And that is my final answer. Example 2. 2x squared plus 1. It's my divisor. 8x to the 4th, 5x to the 3rd, 7x. So a squared's missing. 7x and the 2. 4, 3, I'm missing the 2. So I'm going to put a placeholder for that. Okay. 2x squared. And the 1, I can put a placeholder for that, but I don't necessarily need to. I need it definitely here. Okay, so I don't put a placeholder in my divisor, I put it in my dividend. So 2x squared plus 1, I'm doing 8x to the 4th minus 5x to the 3rd plus 0x squared plus 7x minus 2. So again, I'm going to have my work area. I take my first one, 2x, and then what do I need to multiply? 2x squared to multiply to get to 8x to the fourth. If you don't know, that means you're dividing. 8x to the fourth divided by 2x squared gives me 4x squared. 4x squared. This is technically, so now if you want to know how many terms, this is technically 1, and then your 0x squared and your 1. That's technically 1, 2, 3 terms. 1, 2, 3. However, it doesn't matter if you just put it up there. So 4x squared. See how it kind of goes over its perspective one that you're dividing by? Where this one, x squared, also went over the x squared. Tricky. Cool. All right. Take your 4x squared. You're multiplying it by what? Your divisor, 2x squared plus 1. 4x squared times 2x squared is 8x to the fourth. 4x squared times 1 is 4x squared. So here's 8x to the fourth. I'm coming all the way over here to put 4x squared underneath that one so they line up. They're both positives currently, but what do I need to remember to do? Change their signs. This comes minus and a minus. This cancels. This one comes down because there's nothing with it. Negative 5x to the third. Zero x squared minus 4x squared is negative 4x squared. I'm bringing down the rest, plus 7, bringing down the minus 2. Okay. So now, first one, negative 5x to the third over 2x squared. All right. Not a great problem. That's okay. Don't be scared. Negative 5 over 2, nothing happens with that. X cubed over an x is an x. So I'm putting up a negative 5 halves x. Okay. I'm taking that negative 5 halves x, and I'm multiplying it by 2x squared plus 1. Negative 5 halves x times 2x squared. Remember the 2 in the denominator would cancel out with this 2 that you're multiplying. So it gives you negative 5x to the third. Negative 5 halves x times a 1 is just negative 5 halves x. So I have a negative 5x to the third minus 5 halves x. Oops, it doesn't go there. I lost an x here. Erase. Goes there. I put my x back. Draw my line. Remember to change your signs. This then becomes a positive. Positive. Cancels. This comes down. Negative 4x squared. Now you have 7x plus 5 halves. 7 plus 5 halves. That's 2. That'd be 14 because you're multiplying them both by 2. So that gives you 14 over 2 plus 5 over 2, which is 19 over 2. So I end up getting plus 19 halves x and then my minus 2. Okay. What do you need to multiply? 2x squared by to get to negative 4x squared. If you don't know, you're dividing. Negative 4x squared divided by 2x squared. That gives you negative 2. So I put minus 2 up there. I'm taking my negative 2, multiplying by my divisor, which is 2x squared plus 1. That in turn gives me negative 4x squared. minus 2. That goes here, negative 4x squared minus 2 here. Remember, change your signs. Cancels. This one comes down. 19 halves x. Oh, this one cancels too. So this is my remainder. How do I write it? I write my quotient, 4x squared minus 5 halves x minus 2 plus my remainder, which is 19 halves x, all over 2x squared plus 1. Yes, this looks terrible, but when we're doing long division, it's okay to look terrible. I know we have a complex fraction. We normally don't leave them like that. Okay. Synthetic division only works when you're dividing by a binomial degree of 1. So up here, this is a binomial, but its degree is 2. So we can't do synthetic division. You have no other choice but to do long division. No other choice. This is a binomial. Its degree is 1. Okay, so this I can do synthetic division. This is a binomial. Its degree is 1. So I can do synthetic division. This one's trickier than this one. So how we do this. There are different ways to do it. I take my x minus 1, what I'm dividing by, set it equal to 0, and I get x equals 1. I put 1 in a box, okay, where some people draw this and do a 1 here. Your coefficients, you have to have a placeholder. So this goes 2x to the third. There's no squared, so 0x squared minus 1x plus 3. My coefficients are 2, 0, negative 1, 3. So people put here 2, 0, negative 1, 3. I'm leaving a gap here. There's like a gap here. I'm going to put numbers here. I'm going to leave a gap here, okay, and draw a line. Your first number always comes down, 2. Then you multiply. 2 times 1 is 2, and it goes in the next spot. Then you add. We don't subtract, we add, because technically we already changed the sign here. Add, that gives me 2. Again, multiply. 2 times 1 is 2. Put it in your next spot. Add. Negative 1 plus 2. 1. Multiply. 1 times 1. 1. Add. 3 plus 1 is 4. Last one is always your remainder. That's my remainder. We depressed this polynomial. We divided the polynomial by a degree of 1. So think about it. What was 2x cubed divided by an x? It would be a 2x squared, right? So you always subtract 1 from your degree because you divided it. So it's 2x squared plus 2x. So you're going down, and then your constant plus 4 over, what did we divide by? X minus 1. That's my answer. If you are looking at it this way and you've seen it this way, this one comes down. You multiply still, same thing. I just wrote it in a different way. Put it here. Add 1. I need to multiply correctly first. Get me out of jail. All right, here we are. 1 times 2 is 2. Add, you get 2. 2 times 1, 2. Negative 1 plus 2, 1. 1 times 1, 1. 3 plus 1 is 4. Last one is your remainder. Same numbers, same thing. divide it by 1, depress your polynomial by 1 degree, 2x squared plus 2x plus 1 plus your remainder, 4 over x minus 1. All right, so this one's a little trickier because it says 2x plus 1. You take 2x plus 1, set it equal to 0, subtract 1. 2x equals negative 1. Divide by 2, x equals negative 1/2. So I'm going to put negative 1/2 in my box. Coefficients. 3, 2, 1, 0. Great. So, sorry, I did exponents. I said coefficients. Exponents are 3, 2, 1, 0. Coefficients then are 2, negative 9, 7, 8. Leave a space, draw my line. First number always comes down, 2. I'm doing half of 2, and then I'm going to make it negative. Negative 1/2 times 2. Those cancel, so it's negative 1. That goes here. Add, negative 10. Negative 1/2 times negative 10. Those cancel, it gives you 5. Think about it, half of 10 is 5. 7 plus 5 is 12. What's half of 12? You're just dividing it by 2 because that's your denominator. That's 6. Make it negative, and you get 2. What's that 2? That 2 is called your remainder. This is not your answer. Oh, well, on the last one it was. Okay, so it is not x squared, 2x squared minus 10x plus 12 and then plus 2. Look at this. 2x plus 1 what's different? It's the same equation. 2x to the third minus 9x squared plus 7x plus 8. 2x squared minus 9x squared plus 7x plus 8. Same thing, but I have a different answer because of this 2. So you must divide quotient by that number, which is 2. So this is my quotient, so I have to divide all of those by 2. X squared minus 5x plus 6. You don't divide your remainder because it's already getting divided by the 2x plus 1. So now, do we match? X squared minus 5x plus 6 plus 2 remainder. How did I get a remainder of 4? No, I'm on the wrong problem. Remainder of 2. There it is. So, trickier. These are trickier. If you want to just do long division and not have to think about the dividing, then you don't have to do that. Page 3. Remainder theorem. Ooh. So, look at example 3. What was the remainder? Look at example 3. What was the remainder? Example 3, our remainder was 4. Okay, our remainder was 4. It says P of x divided by x minus a, then the remainder is P of a. So this means what? It means that if I did on example 3, I have the x minus 1. If I did f of 1, is it an f or is it a p? What do I have for my functions? I don't have anything, so I'm just going to call it f. If I have f of 1, if I plug that into my function, so if I said f of x equals, what's my function? On example 3, 2x cubed minus x plus 3. 2x cubed minus x plus 3. So if I do f of 1, because I was dividing by x minus 1, okay, and then this is a, so this is like saying f of a, f of 1, 2, 1 cubed minus 1 plus 3. That gives me 2 times 1 minus 1 plus 3. This is just 2 minus 1 plus 3, which is 4. That was the remainder. So here, on example 3, the remainder is the same thing as if you plug it in. Why does that matter? Because now I have a coordinate 1 comma 4. And that coordinate 1 comma 4, is that a 0? No. So that means this is not a factor. So x minus 1 is not a factor. So use the remainder theorem to evaluate. And if we do f of negative 3, we do 4 parentheses negative 3 cubed plus 10 parentheses negative 3 squared minus 3 times negative 3 minus 8. Okay. Negative 3 cubed is negative 27. Negative 3 squared is 9. Negative 3 times negative 3 is a positive 9 minus 8. All right. 4 times negative 27 is negative 108. 10 times 9, who doesn't love that? 90. I'm going to do 9 minus 8. That's 1. Okay, I can do 90 plus 1, or I can do negative 108 plus 90, then plus 1. You should get negative 17. So what does that mean? That means if I had an x plus 3 and I divided it, I would get a remainder of negative 17. That means it's not a 0. It's a coordinate, negative 3 comma negative 17. This is also the remainder. That means it's not a 0. That means that this is not a factor. So if the remainder is 0, then the value is a 0, x-intercept a root, and x minus a is a factor. So we want to show x minus 4 is a factor. So what do? We do x equals 4. Okay, x minus 4 equals 0. So I'm going to put 4 in my box. And I'm going to do my synthetic division because it's a binomial. And it's a degree of 1. I'm looking at my exponents. My exponents go 4, 3, 2, 1, none. Great, I don't need a placeholder. Coefficients, negative 2, 16, negative 34, 16, negative 32. Drawing my line, leaving a gap, first number comes down, negative 2. Multiply, negative 2 times 4. So we're multiplying. That gives me negative 8. It goes in the next spot. 16 minus 8 is 8. I'm multiplying. 8 times 4, and it goes in my next spot. That's 32. Add. That gives me negative 2. I'm multiplying. Negative 2 times 4 is 8. It goes on my next spot. It's negative 8. 16 minus 8 is positive 8. I am multiplying. 8 times 4 is 32. Put it in your next spot. Add. You get 0. That's the remainder. So what do I know? That x minus 4 is a factor. Okay. So if I asked to factor this, if I was to ask to factor f of x, I now have one of the factors, this one that they gave me, x minus 4. So I put the factor here, boom. Okay. Let's write this part. This is my quotient. What do I now have? It was a power of 4, so this is going to be 3x cubed squared, go down, x, and your constant. Plus, and that one's a plus. So you have 2x cubed plus 8x squared minus 2x plus 8. Do they all have something in common? Do they all have something in common? Not an x, because the 8 doesn't have an x, but they all have a 2 in common. I'm going to take the 2 out. I'm left with x cubed plus 4x squared minus x plus 4. I lost a negative somewhere. Negative. Negative. Oh, then let's take negative 2 out. Sugarland. Erase. I'm taking negative 2 out because my first one's negative. That gives me x cubed. Taking negative 2 out. Minus 4x squared. Taking negative 2 out. That gives me plus x. Taking negative 2 out. That gives me minus 4. Close. This negative 2 is going to go in front. So I have to make a little bit of room. So I'm going to erase. I'm picking to erase. I'm going to make a small equal sign. And I'm putting negative 2 out in front. Group the first 2 together because it's 4 terms. Group the last 2 together and remember the plus sign in between. Negative 2 is already gone because I put it there. What's in common out of the first 2? X squared. I have x minus 4. Only a 1 is in common and I have x minus 4. So they both have an x minus 4 and an x squared plus 1. I cannot factor this one anymore. So I now have an x minus 4. Oh, look, I already had an x minus 4, so it's going to be a squared. And then I had x squared plus 1. Okay, because it was originally negative 2. Our original one was x minus 4. Then we have another x minus 4 that we just factored, x squared plus 1. This is x minus 4 quantity squared, and then x squared plus 1. This is my factors. This whole thing are my factors. My degree should match. I have 2, and 2 is 4. Degree is 4. This is a positive, this is a positive, this one's negative, and it's negative. Negative 2 is my only coefficient. The other ones are 1. So negative 2. It would multiply to give me that. Okay. What's the difference between a factor and a 0? Factors are factors multiply. To give me the original polynomial. A 0 is an x-intercept. Or a root. When y equals 0. So an x-intercept, remember, would be a coordinate. It'd be some number, comma, 0. So this, what we know, is x minus 4 is a real number. X minus 4 is x minus 4 equals 0, and it's 4, and it's there 2 times, and that's why it's tangent. We didn't know on when we find real zeros, we don't know that that happened. All right, I could find an x-intercept because if I look at it in the expanded form, the x-intercept is negative 32. And so they have an x-intercept here at negative 32. I mean, a y-intercept. Oh, y-intercept, sorry. So we would think that since both ends are down, you're like, oh, it's down, down. But with your y-intercept, we would be thinking that it just does this. Okay? But because there's this x squared plus 1, that's what gives it this little bump thing. But if we were to graph it, we would only have like this. That's all we would know for a rough sketch. We wouldn't know this unless we use some kind of graphing utility. That is it. Have a great day.